Struggling with math? You're in the right place. Welcome to Explaining Mathematics, the channel where we simplify tough problems, break down complex formulas, and turn confusion into clarity. From basics to advanced topics, we explain it all step by step. Let's start solving.
Hey everyone, and welcome. Today, we're going to dive into one of the most elegant and honestly mind-blowing ideas in all of mathematics. It's a single, beautiful formula that connects two worlds that feel like they should have absolutely nothing to do with each other: the world of exponential growth and the world of circles and waves. Let's see how this incredible connection gets made. And here it is. This is our star player for today, Euler's formula. And yeah, I know it might look a little intimidating at first glance. You got E, I, cosine, and sine all crashing the same party. But trust me, this equation is the secret key. It's the Rosetta Stone that lets us translate between two totally different mathematical languages. Now, here's where it gets really wild. If you take that formula and just plug in one special number, you get this stunning result: Euler's identity. It ropes in the five heavy hitters of math: E, I, pi, 1, and 0, and links them all in one impossibly simple statement. It's so clean and so profound that people call it the most beautiful equation ever written. But that's the big question, isn't it? I mean, how on earth can these numbers be connected like this? The number for growth, the number for circles, this weird imaginary concept, the idea of one, and the idea of nothing, all tied up in this neat little package? It feels impossible, right? But as we're about to see, it's not magic. It's pure, beautiful logic. All right, so to crack this thing open, we've got to properly meet the players. Let's do a quick roll call of the 5 famous constants that show up in this incredible identity. Each one of these is a legend in its own right. First step is E. This number is all about growth. It's basically the universe's speed limit for any process that grows continuously. Think about money and a bank account that's compounding interest constantly, every single nanosecond. That's E. Next, an old friend, pi. Everyone knows pi, right? The rock star of the math world. It's the magic number that perfectly relates a circle's width to the distance all the way around it. It is the heart and soul of geometry. Then there's I, the so-called imaginary unit. It's the square root of -1, which I know sounds like it just breaks the rules. But what I really does is it blows the doors wide open on our little one-dimensional number line and gives us a whole new second dimension to play in. It's a total game changer. And of course, we've got the number 1. Simple, right? But it's the OG, the foundation of everything. It's the whole concept of a single thing, the building block for all other numbers. And rounding out our cast, we have 0, the idea of nothing. It might not seem like much, but the concept of 0 was absolutely revolutionary. Without it, modern algebra just wouldn't work. So there you have it: growth, circles, a new dimension, unity, and nothingness. What a crew! Okay, so how in the world do we connect all these ideas? Especially E, the growth number, and pi, the circle number. They seem like they're from different planets. Well, the answer is hiding in plain sight, right back in that secret formula we started with. So, on one hand, you've got exponential growth with E. Picture a rocket taking off, just going faster and faster in a straight line up. On the other hand, you've got sines and cosines. Think of a wave or a Ferris wheel, something that goes around and around in a repeating cycle. They couldn't seem more different. And this is where Euler just blows our minds. Euler's formula comes along and says, hey, guess what? Those two things, they're actually the exact same idea. It says that exponential growth, but with an imaginary exponent, is precisely the same thing as moving around in a circle. That right there is the bridge. Think about it like this. If you grow in a normal, real direction, you just shoot off in a straight line forever. But what this formula tells us is that if you try to grow in this strange imaginary direction, you don't fly off to infinity. You just turn. Your path curves into a perfect circle. It literally transforms runaway growth into perfect rotation. So we've got our key, the formula that connects growth and circles. We've met our characters, the 5 constants. Now it's time for the main event. We have everything we need to finally solve the mystery of where that most beautiful equation comes from. Let's put it all together. Okay, watch this. It's actually shockingly simple. We start with Euler's formula. Now we're just going to plug in one special number for x. Let's use pi. Remember, pi isn't just a number, it's also an angle. It means go halfway around the circle. So our formula becomes e to the I pi equals cosine of pi plus I times sine of pi. So what are those? Well, if you're halfway around a circle, your horizontal position, the cosine, is -1, and your vertical position, the sine, is 0. So that whole right side of the equation just becomes -1. That's it. E to the I pi is just -1. And if you just nudge that -1 over to the other side of the equation, bam, you get the masterpiece. E to the I pi plus 1 equals 0. So you see, it's not magic. It's not some crazy coincidence. This beautiful identity is simply what falls out when you use the formula to grow exactly halfway around the circle. The mystery is solved. It's just a beautiful logical consequence of a much deeper connection. Now, you might be thinking, okay, that's a cool party trick, but so what? What's it good for? Well, this formula is so much more than just a pretty face. It is an absolute powerhouse, one of the most useful tools in all of science and engineering. Its real power is that it's a massive shortcut. It takes problems that are really, really hard. Anything involving waves, rotations, oscillations, vibrations, and it makes them vastly easier to deal with, because you can just jump between the world of trigonometry and the world of exponents whenever you want. For example, remember in school trying to memorize dozens of complicated trig rules, the double angle formulas, all that stuff? It was a nightmare. Well, with Euler's formula, you can basically just derive them on the fly. You can treat sines and cosines like simple exponentials, and all those complicated rules just pop out with some basic algebra. It doesn't just solve problems, it simplifies the rules themselves. And this power gets used everywhere. Electrical engineers use it constantly to analyze circuits. The signal processing that makes your phone and Wi-Fi work, it relies on this. It's baked right into the core equations of quantum mechanics. It's used in wave physics, fluid dynamics. The list just goes on and on. Ultimately, that's the real superpower here. This beautiful formula lets us take messy, difficult problems in trigonometry and geometry and turn them into much cleaner, more manageable problems in algebra. And believe me, that is a total game changer. So Euler's identity isn't just a beautiful statement, it's a doorway, a peek into a deeper level of reality. It shows us that ideas that seem totally separate are often just two sides of the same coin. And it just leaves you wondering, right? What other beautiful secrets are out there, hiding in the language of math, just waiting to be discovered?
If this video helped you understand the topic better, don't forget to like, subscribe, and turn on notifications so you never miss a lesson. Comment below what topic you want explained next. Thank you for watching Explaining Mathematics. See you in the next problem.